In this video, we are going to discuss why we find common denominators when adding and subtracting fractions. Let's look at an example. 2/3 plus 1/4. Now you and I both know that we cannot add across the numerators, as in 2 plus 1, or across the denominators, 3 plus 4, but rather we need to find a common denominator. But why? Why does it actually make sense and work to do so? Why is it necessary to find a common denominator to add these? Well, let's look at 2/3 and 1/4. If I tried to put these two fractions together, how would I be able to accurately describe them? If I brought this piece over here, all I would be left saying was, I almost have a whole. But that is not precise enough. In order to accurately describe these amounts, I need to find pieces that are commensurable, meaning that they measure both the thirds and the fourths. So let's say I start trying to figure out how to partition these, and I start with fifths. It does not work, as you can see, to measure these because here I have a little slice inside a fifth, and same thing over here, so it doesn't work. What about ninths? This works to measure the 2/3, but it does not work for the 1/4. There's a little bit left over here. It's not until I get up to twelfths that I find a match that works for both fractions. If you look at the 2/3 and then slice it into the twelfths, you get 8/12. These are equivalent fractions because it's the same amount, just partitioned into smaller parts. You can see that there's the same amount of gold here, it's just sliced differently and counted differently. The same thing occurs with 1/4. If it is sliced into twelfths, it is 3/12. The 1/4 here gets split into 3 pieces, 3/12 when I break it up into twelfths. So now that I have these equivalent fraction forms that share the same denominator, meaning they have the same size parts, I can add them together and get 11/12. So here you see I brought the 1/4 or the 3/12 over to here, and I get 11/12 all together. So to wrap all this up, finding a common denominator creates equivalent fractions that share the same size parts. Then, because the parts are the same, you can measure the sum between the fractions precisely. This also applies to subtraction. When the size of the pieces are the same, the difference can be represented accurately.